You can do some further diagnostics on the load cell, particularly if it's an older unit. There's a couple things you can check to establish the health of the load cell. Number one would be zero balance. If the load cell's been in use for a while, it's be good to do a sanity check on the load cell. The zero balance is going to be a good check to see if there's been any potential overload or damage to the load cell. If that zero balance is shifted, let's say you have an increased zero balance, let's say it's a negative, it's shifted up or down some way from the nominal, that's an indication of potential damage. Doing a verification of the R-cal or shunt cal is also another good thing you can do. Again, if you see any shift from there, or significant shift I should say, it may be a good idea to get that evaluated. And then if you are suspecting issues with the load cell, please contact us. We do have some more tools you can use to evaluate the bridge of the load cell using a multimeter or other instrumentation options. So we're going to kick it over back to Brian, and we're going to talk about three of our most common or three of our popular load cell options: our 1200 low profile series, the SM series, and the WMC series.
All right. As Elliot said, we're going to be covering three of our more popular options, or products, I would say, our LPs, SMs, and WMCs. We're going to go over just a few talking points to get the best performance possible out of these. Obviously, the load cells are going to give you a signal regardless of how they're loaded, but to get the most accurate data, there's some tricks you usually want to follow. So the first one we're going to be talking about is our low profile. That should be a familiar load cell to interface customers, or interface users, I should say. It's known for its very high performance, high output, and its insensitivity to off-axis loads. Also, temperature performance typically can't be beat on these units. Here's a particular unit shown without a base. Again, we're going to talk about that in a minute here in terms of what the benefits may be from that. So mechanical installation, you've got your load cell, you've got it hooked up, you know you've got your instrument scaled, now you want to get it installed and start using it. Well, there's some things you want to follow from a mechanical attachment standpoint. You can see here is the production unit on one of our cal frames, not quite painted up yet. We've got it threaded in there. You want to make sure when you're threading into what we call the live end of the load cell, which is the center hub on the LP, that you've got enough threads engaging into the load cell itself. If you're getting a load cell with a base, it's going to have a plug inside there, so we usually recommend threading in to where the stud bottoms out and then backing it off half to a turn just to make sure that it's not pushing on that plug. But at that point, you're going to ensure that you've got good thread engagement. The next step that we do for calibration, and again to get the best performance, is we would attempt to preload the load cell. So we would actually put a tension load on it to about 130% of capacity and lightly jam the jam nut. And what we're doing there is we're ensuring that we won't have any repeatability issues due to thread engagement changing through the center of that flexure. So if you can't provide a preload on the load cell, then we do have some torque values available in our installation guide that will do a pretty good job of getting the threads loaded up in a similar fashion. But again, the whole point with the preload is that we've got the threads engaged to a point that is higher than the load cell should see during use. And by doing that, it's just going to help with repeatability and for best performance. Now, the load cell you see there is actually bolted up to a base. If you can see my cursor here, we've got another picture shown specifically, but that's the lower half of the load cell. Always recommend using high-quality hardware, grade 8 or better, when you install it either to a base or to your own mounting plate. We recommend that whatever you mount it to is 2 10,000ths total flatness, and our bases are typically RC30 to 33 on the hardness scale. When you are installing it, we recommend following a star pattern just like you would torque a wheel on a car. Now here's some examples of our LPs. The left one is installed on a base, which is then installed to a mounting structure or some sort of it may be a hydraulic actuator. And then on the top side, we've got a rod end bearing and a clevis. We typically recommend introducing some rod ends if possible, or clevises, just to minimize the amount of bending moment that may be exerted on the load cells. As you know, these are typically axial sensors, and while the low profile does a good job of rejecting bending and off-axis loading, it's always good practice to try to reduce the possibility from that in the first place. So again, here's a load cell pre-installed on a base on the left, and here's an example of a low profile on the plate itself, or a customer's plate or a fixture. And as we mentioned, really want to have a nice hard flat surface for that load cell to react against. Parallel as well is very helpful. In this case, you see a calibration adapter pre-installed on the load cell. That is a feature we offer. In fact, if you look at our calibration grade sensors on our website, you're going to see that they all come with these. Well, why do they come with them? Well, like I mentioned earlier, we recommend preloading. And it's often easier for customers to go with a calibration adapter, where we'll preload it here at the factory and calibrate it that way, so that you'll be able to attach on the calibration adapter end and have good results moving forward that way. So talking about bases, bases are a very convenient way to basically get the same performance out of your application that we get on the cal frames. Again, we calibrate on bases. If you get a base with your load cell, you won't have to worry about all those plate details and making sure things are flat and hard, and it's a lot easier to integrate into your assembly. You end up with a female threaded hole on the top and a female threaded hole on the bottom. Works really well for, again, using them inline on hydraulic actuators and such like that. So typically we recommend customers go with bases if possible. Just makes things typically easier in the end run. All right, so the last part is just a double check and making sure that the load cell is well suited for your application. You want to think about things such as, well, do I need a fatigue sensor for this? What about overload conditions? What about environmental conditions? Do I need to worry about moisture or things like that? And Interface has solutions for all these. And again, if you're not sure, call the factory, because oftentimes your idea of fatigue, a couple 100,000 cycles is really a non-issue for our low profiles, which are good for a couple million fully reverse before you even move to the fatigue. So again, these are just things to think about. Minimize those off-axis loads if possible. Applies for LPs and other sensors. That's going to give you the best performance there.
All right, so another variation of our 1200 series low profile series would be the low profile compression only version of these load cells. You'll notice they have an integrated spherical load button. It's a very convenient loading surface. Also gets a little smaller dimensionally. You'll notice we have counterbore base mounting holes on this particular load cell that's pictured. That also helps to minimize any induced bending moments. That spherical load button should be the only curved surface in the load string. And again, like with the standard universal 1200 series, we would recommend a hard, flat loading surface, flat within 2/10,000ths. We would assume a RC to 30 to 33 hardness on that surface. And then any bearing plates that are going to interface with that spherical load button, we would recommend be hardened to RC 45. And we have a couple examples of what this would look like. Again, we have a compression-only cell with the base installed. We have a bearing plate with a flat surface. I want a single point of contact on that. And again, hardened to the specification. And then the compression-only load cell with no base installed on a mounting plate. Again, with those same scenarios. All right, moving on to another one of our popular load cells here at Interface. This is our SM series. This is a smaller size load cell than a low profile. It's 3 millivolt nominal output. It is it's an economical choice if you're dealing with a budget of some kind. Very, very handy for tension use. It uses our proprietary Interface strain gauges, and is still suitable for tension and compression use. Environmentally, you want to make sure it's also suitable for the environment, as previously discussed. We do have a seal version of this available. It's called the Model SSM for applications with environmental concerns. Okay, so installing this load cell, much like Brian discussed a little bit earlier, we want to have this installed in the load string such that we're minimizing the potential for any bending moment. This load cell is a little more susceptible to bending moment than the low profile series due to the lack of moment compensation. But again, very highly performing, provided we're minimizing those bending moments. We recommend in installation jamming lightly on the flexure, and then obviously some rod end bearings or something to minimize those bending moments. This load cell, it's important to make sure that the live end and dead end are oriented correctly. We'll have an illustration coming up here next that'll illustrate that a little bit more. And then string relieving the cable and securing it in some way, so we're not cycling that cable through and potentially fatiguing it. All right, so this is a good depiction of live end versus dead end. I'm sorry. You'll notice that the cable and the mount surface are separate from the live end of the load cell. So we would want to make sure that the load, or what you're trying to measure, is applied to the live end, and that you'll be mounting to the dead end of that load cell. We don't want the cable or the mounting surface to somehow impact the measurement you're trying to take. In installation here, if you're working on jamming the flexure, you can see the depiction here. You're wanting to make sure that you're not transmitting any torque through the gauged area and potentially damaging the gauges through any moment being applied.
All right, moving on now to our WMC series. These are very popular stainless steel load cells used for tension and compression. They're very popular due to their small size and the fact that they're stainless steel and are sealed. These are often an easy go-to for doing basic testing. They have similar installation notes to the SM. Again, we'd recommend using rod ends if possible. Unlike the SM where you're kind of loading through the flexure itself, these you're going to be loading through the studs. So while it may not be easy to see on that picture, we recommend you don't bottom out the attachment hardware. And you don't really need to jam them either. You can. We do have torque values available on that, but they typically perform best if you leave those just a little bit loose, since again you're loading through the studs on these sensors. As you mentioned, pay attention to the cable. These have pretty good strain relief on them from the factory, but that cable can still often influence your measurement if you're not paying attention to how it's secured, especially in the dynamic tests where you may have some inertial influences on the measurement you're taking. Pretty straightforward though. So we're about wrapping this up. Hopefully we did a good job of explaining how to inspect your load cell, how to understand the model code, to help figure out where you can find more information, especially with regards to what kind of signal to expect from it, and then also what to do with that signal. We've got a lot we could talk about instrumentation, but hopefully, again, you've got the basics there, and then with the mechanical installation, you have a good handle on how to put it into your assembly and how to impart the load through the sensor to get the best results possible. So